Welcome. Today we'll solve a combined gas law problem to find the new temperature of a gas system. Let's start with an example problem. Here's our problem. A gas has an initial pressure of 2 atmospheres, a volume of 3 liters, and a temperature of 300 Kelvin. If the pressure is increased to 5 atmospheres and the volume is decreased to 1 liter, what will be the new temperature? Let's visualize what's happening to our gas. Initially, we have a container with a certain pressure, volume, and temperature. Then we compress the gas, increasing its pressure and decreasing its volume. This change affects the temperature, which is what we need to find. To solve this problem, we'll use the combined gas law. The combined gas law states that P1V1 over T1 equals P2V2 over T2. To find T2, let's rearrange the equation. Multiply both sides by T2. Then we get T2 equals P2V2T1 over P1V1. Now, let's substitute our values. We have T2 equals 5 atmospheres times 1 liter times 300 Kelvin divided by 2 atmospheres times 3 liters. Let's solve this step by step. First, let's multiply the numerator. 5 times 1 times 300 equals 1,500. Then multiply the denominator. 2 times 3 equals 6. Finally, divide 1,500 by 6. Therefore, the new temperature is 250 Kelvin. Let's verify this makes sense. Since we increase the pressure and decrease the volume, we would expect the temperature to decrease. And indeed, it dropped from 300 Kelvin to 250 Kelvin. Remember, when using the combined gas law, first, make sure all your units are consistent. Second, always convert temperatures to Kelvin. And finally, check that your answer makes physical sense based on how the pressure and volume changed.